Welcome back. In the past lessons, we talked a lot about the grid, and I told you that we'd talk more about distributed generation or on-site generation. It's a topic where it really helps to have some exposure to how the grid has traditionally worked and how pricing is set up before we hop in. You understand that now, and we've also talked about how customers are more than ever at the forefront of industry changes, and this is a biggie. Just to set your expectations, distributed generation is one of those areas that deserves probably a module all on its own, but I'm not even sure that would cover it. This is a topic that could probably take up an entire Coursera. But let's jump in and create a foundational understanding so you can be better informed about what's going on currently, as well as what's expected for the future. In the earlier lessons, we talked about big and centralized power creation or generation. If you remember, we talked about coal and gas-fired plants and large-scale renewable energy that's generated and uses transmission and distribution lines to bring it to where the electricity is used, our homes and our businesses. Distributed generation, or as some people call it, distributed energy, means that the source of the electricity is located close to where it's used. It tends to be smaller, as you would imagine, since it's closer and serves a more specific consumer. A telltale sign is that it connects to the distribution system, not to transmission. Remember, we talked about how transmission is the high voltage wire. The classic electric utility model is a centralized power station that ships energy to the users through transmission and then distribution to outlying customers. In a distributed model, we're talking more about the generation occurring on a smaller scale, and it's not centralized. This could be site-specific renewable energy like wind, solar, or geothermal. While there are some large-scale and centralized wind and solar installations, the distinction for this is that there is a different scale. With distributed generation, the generation tends to be a lot smaller and it's not connected to transmission. You'll remember from our previous lessons that transmission refers to those high voltage power lines. Now it's time for a little utility math. Even if you have always hated math, don't worry, it's just a short detour. To give you a rough relative sense of the difference between large-scale generation and distributed generation, I'm going to talk to you about a large-scale utility plant. It might have a capacity of more than 1,000 megawatts. If you're sitting there thinking, mega what? You're not alone. The rule of thumb is that 1 megawatt powers 1,000 homes. And that means a 1,000 megawatt plant could serve 1 million homes. Mind-boggling, isn't it? Especially when you think about the fact that there are many plants that are bigger than that. While I've heard some differing opinions on it, distributed generation power is more like a fraction of a kilowatt to about 100 megawatts. For people who like math, there are 1,000 kilowatts in 1 megawatt. Even though people don't always agree on the threshold or the range, really what you need to know is that distributed generation is smaller, although not necessarily small, and not centralized, and not connected to transmission. Something else you need to know is that while 1 megawatt powering 1,000 homes is a rule of thumb, it's not always right, because it depends on the generation source, specifically the type of generation source, how efficient it is, and a number of other factors. The number of homes powered by solar depends on average sunshine, temperature, and wind, just to make it more clear. So it could be that 1 megawatt of solar actually powers only 200 homes or 400 homes in some instances. That's just an example. The fact of the matter is it varies considerably and it's pretty complex to calculate. But we're not here to do math, so let me tell you what this looks like in real life. Take my neighborhood, for example. A number of folks have installed solar panels on their rooftops, and just down the road on a larger scale, but still distributed generation, there are solar panels on the local elementary school roof. And even further down the road, a developer has created a solar installation that powers an entire development. You might be surprised to learn that utilities themselves recognize the value of distributed generation. Why are we hearing so much about distributed generation when it wasn't such a talked about topic before? It's because customers are getting more interested in it. It's actually getting more mainstream. Here's what Dean Hubbock of United Power has to say about this.
Sort of the large changes that we've seen, the solar industry or distributed generation is becoming more and more acceptable and more mainstream. There's more options, more opportunities, and the cost is making it just much more effective.
And what this also means is that the industry paradigm is shifting. It used to be that transmission systems were known as the way to transport electricity back and forth across long distances. And now, distribution systems are becoming bidirectional as well. If you think about solar, there are times when someone is producing more electricity than they use, and the electricity is going back into the grid. This wasn't the case before when it was like a one-way street.
There certainly are a lot of changes coming. Technology has driven us into different directions. We are on the brink of getting low-cost distributed generation in the form of solar electricity. And it's changing the way utilities have to interact with customers. The grid is no longer a one-way distribution as much as it is a two-way transmission of power. So the industry is changing. That puts pressure on the regulatory side. For the last 100 years, most of utility fixed costs have been recovered in variable rates because it worked and because there was either consistent load or increasing load. With distributed generation, that turns it upside down, and the variable amount of usage or sales is declining for many utilities, which puts pressure on them to recover their fixed costs in different ways, and then that creates some backlash.
Dean Hubbock of United Power describes how the industry is shifting and the implications this has on distribution systems.
The industry, when we started, the transmission system was the two-way street. That's where everything was occurring. When we started moving down to the distribution system, and that's from the substation into the end user, it was a one-way street. And so we didn't have to worry about what was really happening, being put back on the grid, because nothing was occurring. That is now stepping down into the distribution system, where our distribution system is becoming a two-way street. And so we need a higher level of monitoring, more controls, to know more what's going on. And people are going to be expecting us to be more of an expert of what we're doing and how we are doing it. And so I see the future actually being moved to the distribution side, where we have much more distributed generation, much more resources, and being more transactive on the distribution system than what we're actually seeing, the way we've been seeing on the transmission system.
Dan Hodges talks about how an increased interest has resulted in munis responding.
When you look principally at the adoption of disruptive technologies, take distributive solar technologies, for example, we see a lot of consumer demand for those products. And when your ratepayers are the voters for the city council that happens to be your utilities board, that really sort of gets results. If you show up to a city council meeting and you're demanding that your utility deliver a certain product, typically city councils listen to their voters. And that's why you see pretty rapid adoption of some of these disruptive technologies in the municipal utility space.
We've talked extensively about the fact that while customers are very interested in renewable energy, most are not willing to give up knowing that their electricity is on when they need it, 24/7. We also know that the sun doesn't shine all the time, and sometimes the wind doesn't blow. When the sun isn't shining and the wind isn't blowing, customers still want their electricity. And where do they get it? The grid. Jerry Mariza of United Power talked to me about the need for balance between generation sources to ensure this reliability.
Obviously, we only make electricity with solar when the sun is shining. People still want to watch television at night, so we would obviously have to have some sort of other types of generation so that you could do that. And I think at the end of the day, that is part of the solution as we move forward, is a balanced approach. We can't do 100% solar and wind. We don't want to do 100% coal and natural gas, but that it's a combination of all those things that put together complement each other and provide the power to people as they want to use it. If they want to do it at 2 o'clock in the afternoon, great, solar will do it. If they want to do it at 2 o'clock in the morning, maybe that natural gas generator is more appropriate to supply the energy at that time. So to me, it's a mixed approach, a balanced approach that we need to move forward with.
What I hope you get from this lesson is that customers are asking increasingly for renewable energy choice in the form of distributed generation. At the same time, they expect their electricity to be there when and where they need it. And this means that even if they have distributed generation, they get value from being connected to the grid. A paradigm shift is occurring rapidly, where centralized power generation is no longer the only option. In a later lesson, we'll talk about the more controversial topic of the value of the grid and how to reflect that in pricing.